Right, hello guys. To be successful in Satisfactory, it's good to know math. To calculate the ratios. For the longest time, I messed around and tried to what's it called, but basically, you can understand math through Turing machine. It's like it has a writing, reading head over a strip of tape. The tape is basically infinite. It's divided in cells, and always a head is positioned over one piece of sequence. And I guess it has like some kind of other logic to it, because it needs to know where to scroll the head to, like to keep things in the memory, like two variables on a one strip of tape. You need to just somehow remember where you need to scroll to, read the values, but like you read them and then you have like a buffer, because when you scroll back and you need to write, then you need to calculate a rule. Well, math is based on the language of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because how do you get number 10? You revert, you take the two unfilled positions, you revert the 9 back to the 0, and then you increase this 0 forward, so it's 1. Because when you reach, let's say, well, how do you get 11? You look at the sequence of 0, 1, 2, 3, you look at the symbol, 1, because, well, we are increasing by 1, but let's say if we were to increase by 4, so we take we find our position on the tape over this 0, and then we go, plus 1, plus 2, plus 3, plus 4, and then we read the symbol, and it turns out it's 4, and 10 plus 4 indeed is 14, right? But let's just take a random number, 9. Oh, it's a good number, I'll take 3 digits, I think. 6. 10. Well, yeah, we can take this 10, whatever, and this one will be non-existent. So let's multiply it by 69, because multiplication, you can't really do multiplication because you need to remember the multiplication table, and you do it one by one anyway. And let's try doing it on this strip of tape, and I think I'll need one extra position here, so, or if not 2, so let's take it here, so 1, 6, 9, and this one will be empty. So I think, yeah, you start at position here, and then, alright, I should have pre-done this, but basically if we take 9 times 1, I'll need a new strip, I think, because it will be hard. Oh, I'll override the value. Yeah. Yeah, it won't work that way, because I'll need to multiply it first by 6, then by 9, then by 60, because 69 times 961 is the same as 9 times 961 plus 60 times 961. Yeah, I think so. So let's take 9 times 1 is 9. Yeah, not to lose the original number. Oops. Yeah, so it's a clean multiplication, but 9 times 6, I should have made. Yeah, in the infinite tape, you would have like you would write it somewhere here. You know, you would define this as an ending point of this input, and then you would, you know. But I'm just simplifying the thing because, you know, you would move the head here, write the 9, then you go back here, read the thing, you know, multiply it, then you move back here, write the 9 times 6. Oh, I mean this one, yeah. 9 times 6 would be don't even know, 54. So yeah, we write the 4, then we're left with the 5. So where are we gonna store that 5? You know, scroll all the way here. Need a third variable, or even if not even the 4th. I'll need another piece of tape here, because I'll end up with 2 numbers and then I'll need to combine them, and then I don't want to lose this original value. And I wanted to overlay them 1 over 1 so it looks nice. But yeah. Yeah, so 5. So 9 times 9 is 81. But this cell has a, where was it? UTU. This cell has a 5 as well, you know, pending to be written into it. So once you done the multiplication calculation, you need to do the, you know, summation. So we write 6 here because that's where the position would be, and here we write the 8. And let's just take the calculator. 961 times 9. Yep, I still can do math in my head. Okay, so we would ideally overlay this number with this one, or not really, I guess. Yeah, so think of this as a section somewhere on the tape, you know, because it's infinite. So let's take the next position here. We're done with the rule. No, not that tool. Move tool. And let's redo the calculation. Oh yeah, I forgot to move the head. Sorry. So we're back to this one. You know, where did I place that layer here? 6 times 1 is 6. You know, you would choose another thing on the tape. 6 times 6 is 18. Was it? Oh man, it keeps changing the label. Crap, can't follow that. 6 times 6 is 18. So we need to write that 1 somewhere, or I don't know how Turing machine would keep it. I guess it would just keep it like this, but then it remembers. Well, yeah, why not? We just write 18 straight up. Yeah. Why am I making it complicated? We just need to remember where we are on the tape somehow. No idea how. 6 times 9 is oh crap. 54 again. But we need to sum it with this 1. So it would be 5. Well, 54, yeah. And then this cell already has an entry. It's not a Z. Well, see, yeah. We need a symbol that is 0 and symbol for empty, because this article says the tape is pre-filled with zeros, but it's not exactly true. Where was it? The tape is being infinite pre-filled with zero, but it's like a symbol for void, like it hasn't been used cell. It's a free cell with nothing in it, so we don't need to do anything with it. So we need a new symbol in our 0, 1, 2, 3, 4, 9. And there's also the extra symbols of multiplication, summation, minus, you know, equals, stuff like that. And then there's a void symbol. So there we go. We have like a, where was it? Finite table of instructions. Finite table user specified instructions. Okay. Alrighty then. So now, to complete the multiplication, we need to overlay these two guys. Where was it? This one. Like this. Because 60 is a decimal, you know, place. This 9 is a well, digit space, or how do you say it? A single space. And then the one in front would be 100 space, you know, 1000 space. So we need to overlay them like this. So 9 is overlaid with nothing, so it becomes a 9. I need a new thingy again. I'll just write it. Oh, I need one extra position. I'll make them into empties for now because I need to know where to click. So this one becomes 9. You know, 6 plus 4 is 0. Well, basically it's 10. It has 6 plus 8, 14. So 14. But this one already occupied, so it becomes a 15. 8 plus 5, 13. Yeah, so this is how the Turing machine works. 14, yeah. And then the 5 is remaining, so it becomes a 6. So let's see. Oh, I lost my original number. Was it 961? Can't remember. Times 69. Yeah, this is what happens when you don't have enough thingies. Yeah. Can't remember my original number. Can I scroll that far back? 961. Something went wrong? I don't know what. I guess I messed up somewhere here. Let's see. So this one should be 9. This one is 0. But then I messed up here. Why did I mess up? It should be a 3. Let's see. 961 times 60. Yeah, I messed up this what? I messed it up so badly. How? Original number. So 6 times 9. Okay. It's too bad these don't have labels. So the initial thing was right. 6 times 1, 6. Or not. No, it's like a 60. So 0 is here. 0 is 0, so you know. 6 times 1, 6. 6 times 6. Oh, shy. Right. I think I messed this one up. I said 18, didn't I? 6 times 6 is... Oh. Oh, what is it? Oh, I'm blanking out. 6 times 6. I can just override this number. But what is 6 times 6? 5 times 6, 4 times 6. I know 6 times 8 is 48. 42, 6 times 7, 6 times 6. 36? Really? Okay. So, where is the copy of B? 6 times 9 would be... I mean... 6 times 9 would be 54, so... 54... 4 plus 3 would be 7, 54. And then we have our number, was it? Yeah. Sorry about that, but yeah, so back to this one. Should be 9, should be 0, should be... Oh, right, yeah, 10, sorry. It should be 12. And this one is 13 then. 8 plus 7, 15. I'll write this one first, then 15, because it's easier for a human. Machine wouldn't be confused, but I am. 15, 16, and then 6. Was it that number? Yeah, 309. So you see, we don't do the calculations on the whole numbers. We just do them on the symbols, on the spaces, on the cells, you know. And you'll find out where it's useful. Well, I mean, useful in the sense that you need to know how math works. Because Satisfactory doesn't have an in-game calculator, you know. Back to Satisfactory. I'm trying to make the recipe of electromagnetic somethings. I should turn up the volume. It's very loud in my ears, but for some reason the game, when it captures it, it's very quiet. So let's see, we need like the radioactive part, the uranium cell. Oh yeah, I'm in the... For some reason it de-equips everything. You need to re-equip your speedy boots. But basically, yeah, I'm making the encased industrial beams here. I'm just using concrete. Concrete is like 600 per... or 400, I can't remember. No, it's 600 concrete, because that's the maximum I could get from that node. These are, you know, there are enough coal, and that's a pure node of I'm using the slow standard recipe, you know, like coal and iron ore. And then I'm making a bunch of, was it like 15 manufacturers of pipe. Come on, because they're all productionalized. So these two are working like 5, these two are working like 5, that's 10, and then 2 extra. Oh no, was it 13 or 14? 14, I guess, because this one is like 2 buildings and this extra one as well I added. Yeah, so I got 14 things, 14 buildings producing the recipe of, let's see, it's like it eats 30 ingots per minute, it produces 20 things. So there's where the math comes in. So we have 14 buildings, so you need to times 14 times 3, and it's a pretty simple calculation actually. How could I write it on my infinite tape? So 14, you know, it will be a 0 in the end, but basically 3 times 4, was it Oh, I should write here, so not to lose the original number. So 3 times 4, was it 12? Yeah, and then 3, is it 42? And the 0 at the end, of course. Let's check it out. 14 buildings times it eats 30. It eats 420 steel ingots, but the Mark IV belt, as you can see, Mark IV belt can move 480 resources, so we're keeping inside that limit. And let's see, was it 400 here? I can't really remember. Like there's a there's a limestone node here. It's a normal node, but the Mark III miner can only pull out 600. And then we're using the fastest concrete recipe. Well, basically, I don't really like to use this one because it doesn't have all the recipes yet. But yeah, this is the fastest one, 80 per minute. And I'm using like, I think I'm using 2 refineries. Yeah, I'm producing 400 per minute. That's the maximum I can get. Can't get it without getting an extra node involved. This one is disabled. No, it doesn't have an input. So that's the encased encased industrial beams for this recipe. I'll show you the electromagnetic units, and this has a recipe, but it's not showing up in this tool, so you have to use the manufacturer. Check it out. Can I make one? Dang, it's not even here. I don't want to use the alternate recipe because you won't have... Well, it's not guaranteed that you would have it. Oh crap, what am I doing? The assembler. Yeah, so this one only needs the radioactive part and concrete. And this one is like, you need 2 refineries to make the uranium pellet. One refinery you make the sulfuric acid, and then yeah, you use sulfur and water, and then you add uranium to the next refinery. You add this acid, and you, for some reason, you end up with acid. Like, how does that make sense? Like, this recipe makes no sense. Why does it take it in and spew it out? Like, I don't know. For balancing issues or something? To make the numbers rounder? I don't know. Where's my ride? Like, I haven't got the electromagnetic control unit factory balanced out yet, you know, by the numbers. Just because it's too time consuming to keep building and rebuilding, and you know, to get all the belt mathematics right and whatever. And we need a faster transportation. So I built my base over the central coal, as I call this location. It has a close by location of oil. It doesn't really have much water, but it has a proximity of, well, yeah, proximity of sulfur. You know, almost everything you would want. Alright. It's still the exit of Northern Forest. Through here, a bit down. And here we go. Somewhere here. Was it this turn or one of these turns? Yeah, that leads to the lower base where the nodes are, but to actually drive up to the base you need to use this ramp. Right, I marked it out as well. So convenient ramp. You have this Caterium node here, then uncovered iron node. Yeah, so this base has all the resources to produce electromagnetic control unit, or however it's called. Control rod. So let's take a look at the base. Do I have enough? So that's the iron ingot production, that's the steel production, that's the pipes. This one produces stator. This one produces AI. And then the AI components, the sheets, the quick wire, and the ingots. You know, mostly this process mostly takes copper and some steel, because in this setup I'm using the copper on the steel production as well, so you don't need too much Caterium in this setup, but I'm using the alternate recipe here just to make it a bit more, you know, smaller, I guess. But yeah, we have the AI limiters, we have the stators, alternate recipe for stator, and then the standard recipe for the unit. And you know, I make the pipes here. Now first you make the ingots, you get the steel, and well, this is an alternate recipe because it's the fastest steel recipe. You know, you have 45 per minute standard, you have 60. This one was, yeah, I'm using, I guess, the second fastest one then. Coal and ingot. I could have used this one, I guess, because the... But you need like alternate recipes to get it, I think. Well, to get it fast. Or no. Or maybe not, but you need this one. Oh no, no. You can get it standard because the rubber recipe is the best one to make the residue. It produces something useful you can use, the rubber. It produces 20 of the residue, like I can show you. Like residue, you can get it from here, but it uses 60 to only produce 20. This standard recipe takes 30 and produces 20 plus extra rubber. Yeah, well, this is the standard, I guess, then. Yeah, this one takes 30, produces 20, but it produces like something unusable, so I guess you could use this one. The power consumption is the same everywhere, yes. And then there was one more. Or was there not? Residue. Oh, the ineffective one, yeah. So this one only produces 10 fluid. We use 30, but you know, we end up with less. And I think that's it. Which one is this? Oh, there are two of them. Which one was that? This one? And that one? Oh, well, whatever. You get the point. Yeah. So now, if we look at the... Wow. Oh yeah. To get the ratios, you look at the most expensive thing in the biggest number that, you know, because we're limited by belt. I'm using the belt 4 because it's very, well, quote unquote easy to make than the aluminum sheet. That's quite a process and quite up the tiers in a base milestone. But basically, if you look at the recipe, it needs 6 stators and 4 limiters, right? So if we were to take X, so somewhere, so 6, 4 was, yeah. Yeah, and then we take the recipe for, I mean, I already know this, but the quick wire takes up the most space on the belt, right? So 990 per one factory. And well, yeah, I'm using both. The stator, you know, needs quick wire, and the AI limiter by default has like one recipe, I guess. So it takes quick wire. And well, basically, of all the other products involved, this one is 100 per minute, this one is 25 in that recipe. This one is 1660. So you can find out that actually we'll need those numbers. 1660. Let's say, well, let's just take pipe. Oh, 16? No. Oh. Quick wire 60. We'll push down the multipliers through the ranks. So if we wanted to produce instead of was it 1? 4 parts per minute. Magnetic unit 4. So if we wanted to produce like multiplier by 2, you know, twice as much, for example, we would need to push down this multiplier through the ranks, and it would accumulate. Because the way it works, we can't. Well, I mean, we consume 4. Let's start with the stator then. 8 stators. So we're producing more, a bit more than we're consuming. So the ratio you would find is, or the multiplier, 4 divided by 8. No, but 6 divided by 8. That would be multiplier number 1. The down multiplier. And then to increase the production we would take 0.75 times 2 and times this number to find out. Let's just temporarily try it. This number. Is it 90? But basically you would need 1 full building, and then plus you end up with 30. So I guess 50% of, you know, quick wire production. Actually I lost the plot where I'm going with this video because I need to go back and try out the numbers, how they actually work. Let's take the other one. Limiters 2500. Was it quick wire again? Limiter 5 was there. The multiplier here is 4 on 5. And then the pipe is made directly. But then it depends on 60, 40, 40. Steel uses coal and ingot. It's a very complicated recipe for the calculations, and the quick wire is still ingots. Power message is in the way. 5, 37, 5, 90. Copper ingot, barium ingot, 7.5, 60. I'll take this example, 37.5. I'll take this example first because these are straightforward. These are only, you know, like there's just one smelter and that's it. $45.15. Got there more. 45 was it? Oh. Huh. Was it barium ingot? 45. Am I tripping out? 45.15. Yeah, so I can't remember how much did I have. I'm making it 22.5. Oh. Did I really need that much? Can't remember. I mean, I got 7.5. Oh yeah, 7.5 and 7.5. Yeah, I need like, yeah, I remember I added the third one. Now basically the way you end up with those numbers is you go through the multipliers. The multiplier currently is 1. Yeah, but quickwire is a bad example because it relies on 2. Because the stator takes the quickwire and the limiter takes the quickwire, and it's not even pipe. It's the sheet. How did I mess that up? Sheet is 25. Yeah, I'll just go through the copper ingot production. Was it 30? It's 1:1. So the sheet only takes, what was it? I'm using the standard recipe. You could also steam it. It's not in this building. It's in a refinery, but it needs water. You could also steam it, but oh man, 20 tons. Yeah. Sheet 10. So the way you would go with the production multipliers, you need the multiplier here. So 25 divided by 10 is 2.5, because 10 is an easy number to calculate with. and then you have this production 30-30, you know, because it's 1-to-1, well, but we need 20 on 30. So to find out how many well, how many of these basic things we need of the like copper ingots or copper ore or whatever, you know, the ore is the starting one, so to produce how many is that? Is it a multiplication? 25 times 0.8. I guess to produce 4 limiters we need 20 sheets per minute, and that will give us, you know, like this building will produce at 100% efficiency. I think that's how it works. So to find out how many smelters we need, we just push the multiplier down. So that would be 0.8 times 2.5 times 1. Well, not really. We'll know how much we need on the belt. Let's see. So this one, I guess we can do the full chain. So this one times this one times this one. Oh, I skipped one. Let's redo it. So the limiter, the sheet, the ore, I mean the ingots. Really? Well, I guess video fail. Don't think it's that little. You need way more. I think, oh right, I didn't take the sheets. I skipped the one multiplier here. Because I guess you need to multiply it this way. Oh, or rather, this 40. No. I mean, if we go the brute force way, or rather, I remember doing the calculation on the sheets. 2.5 means the amount of buildings, right? Because if you have 2 buildings producing this, Right, yeah. Yeah, you need an additional multiplier here. And then how did I get this number then? Oh, yeah. Now I get it. This number should be 2.5 times bigger. The one we use in the calculations. So yeah, so there's like the recipe time and then there's the production time. So let's see. We need to take 2.5 times this number. Yeah. That's what we end up on the belts. Yeah. And then yeah, see, there's no real space to need to mark them out somehow. So let's just take it for now. You can organize it in a table later, but yeah, so this one times this one. Or no. 22. What happens if I put 22? Yeah, I guess this last cell should be the production value. This multiplier times the production. And then C19, what happens? That seems more plausible because, and then there's the additional copper you need to feed into the, was it, yeah, stator quick wire. And then also, well, so yeah, so see, this branch consumes copper. This one consumes copper directly, and this one consumes copper through the quick wire recipe. So to fulfill only the limiter, only the sheets required to make the limiter, you know, 4 limiters, you need 166. So yeah, that's how you do the calculations. Maybe I'm a bit wrong, but you know, it's it's not straightforward, tell you that. What is this pole? Is it my temporary setup? Yeah, but basically it's a real mess, you know. If you want to expand your factory, you need to, the best way is to plan exactly, you know, how much of anything you need, because once you place down your buildings, you know, you have allocated a certain space to it to move. You know, if you then realize that, oh, what happens if I use the steel to produce the encased industrial beams for the final recipe that I'm trying to make? Then you mess up your you know, like you use steel here, and then you mess up your final ratio of copper, because you know you're using it in a steel production as well. And then all your math goes out the window and you end up with less production than you thought you would. So yeah. Balancing out the factory is a real mess. But at least, you know, you can see the recipe. I have these 2 ingredients here going into the final factory. It's not the best way to build I guess. Because I'm feeding all of this through one set of. I think I have 2 miners on copper. Yeah, this input section is a mess because you can't walk through it. Ideally, I would have like, you know, like a wall and then the 3 conveyor openings. Then I would have the same here, so I can walk under it. And then I take the copper from this place over here. This, you can't really drive to this location. It's not easily accessible. You can drive through here somehow, but it's like a very buried entrance, you know. It's like a nightmare to drive through here, so I just, you know, travel by foot. Oh man. There is a slight opening here. Maybe you can drive through it very carefully. But I usually just park on this road and then I come in by foot. You have like a very convenient location of there are 2 pure iron nodes bit there. Copper, there are like, I think there are 3 nodes here. This one is pure. This one is pure. And the little bit somewhere here is another one. It's a pure one as well. Yeah, so that's what I use to create the magnetics. And I can also show you the coal and the... Well, coal is straightforward, but the limestone I use the steaming method to produce the concrete. Yeah, so these are 2 iron nodes, but I only use 1. Pure. Pure. Yeah, but so basically the tip, the big tip to get from this is look at the highest number in your recipe tree, because that one will be the limiter. You know, because the belt has a capped speed. So let's see, I take the limestone from here, I bring it to the water, I bring the ready concrete upstairs, because that's how I use the concrete from here to build all this base. This is the mistake. Yeah, but basically I bring the limestone here, take some water, and I use 4 buildings, is it? And you need like 2 dedicated pipes because it takes 400 water, but the pipe can only move 300 water. So I make... Huh? The number is not beautiful. 120 and I only need 400 though, don't I? So this one should be 280. What's this number all about? Should be 280. Maybe I misclicked it. Oh well. Oh right. I did, but it reverts, so you need to go 1 percentile up. That's good to know. Can't rely on this box. You can only rely on the percentage. Right, I remember, yeah, I typed it in, I went away, but never checked that it reverts. So you need to overproduce the water a bit, I guess. But yeah, thanks for watching. It's been too long and too confusing, I guess. And the call is here. Some nodes are there, some nodes are here. It's like pure. Oh. Yeah, two are here. And the oil is somewhere here. I think this plateau, yeah. There's like a normal, impure oil. And the sulfur, can't remember where exactly. Sulfur is blocked by poison up here, and then there's a normal one here. But it's blocked by poison here, and you need explosives to get through this cave if you want to drive through to it. Otherwise, just build a ladder or a hypertube to get up this cliff, because all this is cliff. And driving around here it's a bad road here. And driving through this axis is poison. And there's another oil here, which you can use turbo fuel, you know, coal from here, and well, sulfur, it's close by, you can make turbo fuel there. So